Okay, so this talk is, I gave this at C-Slug a while ago. This is a talk about my messenger library package, which is, I never want to say a framework, but it's basically a framework for application development. Similar ideas to DQMH or Actor Framework. It's for being able to quickly, on a standard pattern, make interacting processes that communicate with messages. I mostly wrote this about 8 years ago now, 8 or 9 years ago. And it's been on the tools network since about 2015. So this is not new stuff. I consider this well tested and established. Though at the very end, I'm going to show one new feature that I'm working on. Now, there is a series of YouTube instructional videos that I did a while ago that are available through the wiki. So you can actually go there. I will actually go through that example. But the problem is that's kind of a high-level example that uses my sort of templates for actors that have a lot of moving parts. So for this example, for this talk, I want to start with as simple as examples as I possibly can do, just to illustrate the basic concept. So I'm going to try to be as simple as possible, no error handling or anything, just simple as possible. After that, I'm going to try to show a bit about the YouTube example, which you can actually look at because it installs with Messenger Library. And then I'm going to talk about some points about the kind of architectural patterns that I tend to use, sort of as starting points. So to go through the talk, I'm trying to talk about a few simple verbs. Send, to send a message, to reply to a message, to notify someone of something, and to launch a process, to start something running. So first, let's talk about the verb send. Here, sort of a central feature of Messenger. The central idea is the send message method. I mean, it seems pretty basics of any kind of messaging application. And this takes an address and a message, and it sends a message to an address. Very, very simple. But usually in applications, you don't see send a message to an address. You see send a message, put a message on an element on a queue, or fire a user event, or send a notification, or use TCP or something that is more specific, that really makes it only uses a certain type of address. Queues and user events and notifiers are all kinds of addresses, but they're specialized. So the first idea of Messenger Library is to start with a common parent of all these things called an address, or just a send object, and then have queues, user events, and notifiers be children of this. And that allows you to write code that is simple in that it doesn't specify what kind of communication method it's using. So I'll show that here. So this is the simplest thing I can do. It's a simple sender, takes an address, writes a message, sends the message to the address, sends it every 300 milliseconds. So let's go have a look at that. So this code I wrote for this talk, I will make available. I will post it somewhere. So here's the simple sender. Very simple. Takes any address, sends messages to it. Now we're going to have a simple receiver. Simple receiver creates a queue. This is the wrapping, but this is specifying I want a queue. I will create it. I will pass it to the simple sender, so it sends messages to the queue. And then I have a receive method, which is basically dequeue, read the message, and get it. In this case, it's just a count. So if I run this, I mean, it does the obvious. It just counts, very basic. So the interesting thing, though, is then when I use a different one, where I give it a user event. So this creates a user event messenger, which basically just wraps a user event, pass it to the same sender. It's the same one. I haven't changed it or anything because even though I'm using a different communication method. And here, because it's a user event, we have a different API for receiving messages. But basically, again, we receive messages, read them, and they count. And it works just the same. The point is I haven't changed anything in my sender. So the thing I'm gaining by this kind of parent class of an address is make the sender not specify the kind of communication. The receiver specifies the kind of communication because the receiver has to receive it by some kind of API. Now, once we've done that, we can go further. So here's one where it's basically the same as before. I've taken the receive by user event and the receive by queue I showed before. And here's one received by a notifier. I've combined all addresses into a combined address, which I call an observer. and I've sent it to the same simple sender. I haven't changed the sender at all. And the sender can now send to 3 different places. So if I run this, again, I get the same count in 3 different places by 3 different methods. So hopefully at this point you can see that because this is really simple, I'll put it in a more complicated application without changing it or making it more complicated. And I'll go back here. So we can go even further and talk about TCP communication. So here I have something called a simple TCP sender, which basically connects to a remote IP address and service name, and then behaves as if it was an address, so you can send messages to it. So here's the simple sender. Now the simple sender TCP, it's the same guy we had before, but now I've configured a network service. This produces a TCP service with the name of, I should change that, cslug2 2020 on localhost. Now I can run that. And then, hang on, wrong way around. Sorry, once you got into client server, you got to start the server first. Here's my server, which again is the same loop I had before using a user event, but now this is a sort of a network server capable user event. So you can connect to it and send user events over the network. So I'll start that. Now I start my client and you get messages. And again, you can put this on a different computer or this on a different computer and it would work because it's using TCP communication in the background. But again, the simple sender is the same thing as before. I haven't changed it. And this receiving loop, I haven't really changed either. It's the same loop you've seen before. The complexity is hidden. So now the second verb I want to talk about is reply, and replying to a message. This, I think, is missing from a lot of other frameworks where it's not so obvious how to reply. Here, I have a method where I take 2 messages. One, the message to reply to, and then the actual reply message. And the address that the reply goes to is attached to the incoming message. So I'm replying to a message. And messengers in Messenger Library basically have 3 things. They have a label, which is the identifier, text identifier of the message, an optional reply address where to send a reply to, and the data, which is usually an invariant but doesn't have to be. So let's look at a simple replier. Let's close some of these things. Oops, too many things. Way too many things. Okay, simple replier. So here's my simple replier. It's more complicated than the simple sender. It's got to receive a message, so it needs to know what kind of communication method it's using. Here it's a queue. When it receives the message, it writes a reply message, and it replies to the original message. So you see, the address is hidden in this message. We have to attach addresses to our messages coming in to get replies. So let's see, look at this. So here's a first use of this replier. Again, we create a queue for the replier. And then we can send it messages. And these are synchronous request replies. So we send a message, what time is it? And we wait for the reply. Internal to this method, we actually create a single use address, attach it to the message, and wait on that address for our reply. And so you can have it shows here that you can have 2 different loops talking to the same thing, and they both get the proper replies. That's because it's basically request reply. The address is in the message. So this loop can talk to 2 things. If I start it, again, all the stuff comes in, coming in at different rates because the 2 loops are at different rates. Now, another type of messaging pattern, we're starting to get into messaging patterns here, is asynchronous request reply. Asynchronous, you send a message and you don't wait for your reply, but you attach the address of where your reply you want to go to. So here we create our simple replier. We send what time is it, a message, but we attach our return address, which in this case is a user event. Again, you can use anything you want. It could be a notifier or a queue. We create the user event, we attach them to our outgoing messages, and then we listen for our replies as they come in. So this is exactly the same as the other one. The messages go out and the replies come in and we receive them. So we're talking about messaging patterns here. One of the power of Messenger Library, and why it's called Messenger Library, is that it's about messaging patterns using more advanced using simple components with flexible messaging patterns to make complicated things. So the messaging patterns that we started talking about so far are request reply synchronous or blocking, and then request reply asynchronous. Now we're going to look at register notify, which is actually a sort of a specialization of request reply. Register means I will request to be sent notifications, and notify is I will send notifications periodically as they're needed. So it's kind of request reply with multiple replies. So that's the verb notify. So the central method again looks like this. We have to have, I should have done a message one, but this is basically build a message. We need a message, and then we need a registry of who wants what. So the registry says which address should be sent which message based on the label. Let's go back to our find a simple notifier. So the simple notifier is more complicated because in a notification there's sort of two steps. One is you've got to receive a message because you've got to receive registration messages. These are messages that say what information you want and contain the address of where to send the notifications to. And then you have to have a component, which is the list of registered addresses, list of who wants what information. And then also in your process, wherever you want, you have to actually call a notify method, which actually looks up based on the name, time in this case, who wants the time notification, and then sends them the message. So let's look at a simple subscriber for this information. So here again, we have a queue, our simple notifier I just showed you. We send it a registration message. So here's an API where I say, I'm interested in these three pieces of information, start time, time, and count. Once I do that, the notifier will start sending me this information. And then I've got to provide an address to send the information to. Again, it's going to be a user event messenger. And then as the messages come in, I read them and then handle and read them appropriately. If I do that again, I get all the information as before. So again, I got to start the times, and the count. One thing I want to show quickly. If you see in here, I've got three notifications, time, count. These are called event notifications. When these happen, it's an event, which means anyone registered before that time for the notification gets it. Start time is a one-time only state notification. A state notification is something that the registry remembers. So even though the start time happens before the registration message is handled, the information for the start time is still sent. That's because it's actually held in this little wire. So a state notification, if you register for a state notification after it's happened, you still get the message. That's very critical for making it simple in setting things up, because you don't care about the order of who starts when. Because most of the important information is state information, and you will get it regardless of who starts first. So, here we are. So now is another one where, again, same simple notifiers before, only now I've got three of them. I create three queues, start three simple notifiers, send the same registration message to all three, and then I have a loop and it can receive the messages from all the three notifiers. In fact, this information comes in because they're running at different rates. You see this. But there's a problem, and the problem is all three of these things are identical. So they're all sending count messages, identical count messages, and I cannot tell them apart. Now, at this point, you might think that we should go and modify simple notifier to make it less simple so it knows what it is, identifies it somehow. But there's a different way of doing this in the addresses. Let me just stop that. This is called translation, or I call it translation. This is how you can configure an address to do something with the messages that are sent via it. So before the message is sent, the address will translate, change the message as it is configured to do so. So let's show that. So here's the same as before, except now rather than just registering for a count, I'm actually changing, this is a user event messenger, I am changing it to add a prefix from a number. Basically, at the bottom, you can see I could get from 0, from 1, from 2, count. By doing that, I can now identify and separate the 3 different messages from the 3 different notifiers. And this is actually, I saw a talk this morning talk about OOP patterns. This is actually the decorator pattern, where you take an address and you decorate it with extra functionality, which in this case is just to change the label of the message when it is sent. This is very powerful because it means, again, you can take very simple components, don't change them, but you can hook them up and change the labeling of all the messages so that A, they're clear, and B, you can separate them. So here's some example addresses to make it clear. So the usual type of address you might think of is send to a queue, send to queue123, or send to user event 987. Send to a specific thing, but that's it. It's very basic. But here we've just done something like add prefix from 1 to the label and then send to queue. So this is an address. It's a configured address with some translation. We can even do things like relabel temperature and then send copies to more than one address, with one of the addresses also adding a prefix. So you can see how this is very powerful. You can build up an address, which is very complicated, and can take simple components and have them send different types of messages to different places. One thing we actually saw, but I didn't show you when it was doing the TCP stuff, that actually involves putting a message in an envelope labeled send via TCP and send to a queue. That's how it goes through the TCP communication, which is actually run by actors. So the advantage of Messenger Library is a lot of flexibility in the addresses. And that supports components being simpler and easy to reuse. You don't need to change things to use them in a different context or to use multiple things. And it makes TCP quite easy because TCP is all about moving messages around. So once you solve the problem of moving messages, then it can become quite simple to just send a message. So here's kind of a diagram I tried to illustrate the flexibility reuse aspect. If you look at this component, say this is a very simple component. All it does is make a temperature notification. So it watches some thermocouple, measures the temperature, sends notifications off. That can be used in a very simple application where the main is using, say, a user event to receive this information. But then we can reuse this code in a more complicated application that perhaps has 2 temperatures. Rather than have to make things more complicated, we just use 2 copies of the component, still producing temperature notifications, and then we just relabel all the messages so they're clear. So we can tell the prime temperature from the auxiliary temperature. We can send a copy to the UI because maybe the UI wants to display the temperature. We can use a queue instead of a user event, but the UI can use a user event, of course. So we can build a more complicated structure from simple components. And here's just an illustration. If you did this, the main component would have to have some code like this, which takes the 4 addresses from the 4 components, 4 things, sends registration messages with relabeling and prefix and whatever in order to set up this communication. So this is setting up this communication. And note that all this code is in the main thing. So the main thing has the code for the whole application. These guys don't have to be complicated. This is actually a big readability advantage I find, that if I want to understand this application, I only have to look at the code in main, because it's perfectly understandable that this is the thing that produces temperatures. I don't have to look at multiple actors to figure out what's going on. So the last verb I want to go over is called launch, which we're quite familiar with, because this is from actor model terminology. Now, I want to distinguish, I use actor model terminology because the actor model is deeper than just the actor framework. The actor framework is a particular implementation of the actor model, and I use a slightly different implementation in Messenger Library. So there are things in common and things that are different. But the actor model, to me, is about message handling loops, or not really loops, but things that handle messages. And they handle messages because they communicate by messages. In fact, they should really communicate only by messages. So you have different things that communicate by messages. And these things also, I think is important, can be created and destroyed dynamically. So if you need to do something, you can create something to do it. And then when you don't use it anymore, you can destroy it or tell it to, actually you would tell it, you would ask it to shut itself down. So launch in this verb means to create something and get the address of it. One more point, which I think is important, is not always true in all frameworks, is that when you do this, the thing is private to you. If you launch, you are creating something, you own it. You own it and you control it. It's not a global resource that anyone can immediately talk to. You get the address of it, or your caller gets the address of it, and can pass it around or do stuff with that address, but it starts off being private and not peer-to-peer. So launch actor, again, not AF, although this looks very similar to the AF launch method. It takes an object. The object at first represents the actor type. The class says what the type is. And at the end, it ends up with the running actor out. And this is the address of the new actor. That is different than the actor framework, where the actor object is the internal data of the actor. In Messenger Library, the actor object becomes the address or the enqueuer of the actor. And so what this does is launches, it will start an actor running asynchronously. And the actor in Messenger Library is really just the VI. So I'll show you the simplest actor I can make up. So in Messenger Library, I don't know if this works. Can you see that? Zoom in. Steven?
Yes.
All right.
Yes.
So in Messenger Library, the class for the actor really just wraps a single VI. So inside, this is not doing any really kind of OOP stuff except inheriting the ability to be launched. The actor itself, all it has some structure to start. So all this is basically structure to start the actor. And over here, I just have my original simple notifier, which is exactly the same VI as before. So really, it's just wrapping a VI, allowing you to launch or create it dynamically. So if I use this, again, a simple subscriber to the actor, really the actor allows us to clean up. Rather than to create 3 queues and have 3 things out here, we just launched 3 actors. The exact same code as before, I just cut and paste it, which allows us to actually register with the actors and get their individual counts. Now, one thing about using dynamically launched VIs is, well, how do we look at them? If you can't look at them normally, I provide with Messenger Library a couple of tools. And one of them is called the Actor Manager. And this kind of, well, it kind of hacks around the privacy and gets all the running actors in memory and allows you to open their block diagram. So if I click on the block diagram column here, I can open my individual actors that are all running together. And then I can, if I want, I can open the notifier. A couple more things that come with Messenger Library are custom probes. So if I click on the observer registry, it shows who is registered for what. So here, I got a bunch of things of events and state, and I can see that the count, someone has registered for it. They add a prefix from to, and then sending to the event messenger. So that's sort of a debug tool, allows you to see your actors if they're hidden. A lot of the time, most of my actors have user interfaces, so I have a way to get to them anyway. But this is a good backup to find and actually look at the structure of who launched who. So I've just showed you a series of very, very simple things, as simple as I could make it, to show the examples. Were there any questions on that, Stephen?
Not so far, no.
That's not good.
There was a single comment from Derek that this looks a lot like topic aliasing in ROS.
That doesn't, I have no idea what he's talking about.
Okay.
Yeah, it is actually, if you look at some of the websites for some other things, some of these messaging patterns, like to translate a message, do actually exist as concepts at other places. It's where you take a message and modify it, so adapt it to fit from one thing to another. But anyway, I've showed you simple things in hopes that that would give you some idea of what the basic concepts are. In actual use, I use more complicated templates. And this is called the DEV message handling template. You can create this by going to Tools, Messenger Library, Create Actor from Template. There's a few minor different versions. They're all basically the same. And it's more moving parts, but basically it's a way of handling events, which might be messages or user interface events, and then a structure which owes a debt to the JKI state machine that allows you to more easily handle follow-on actions that are required by your main events. And this is the template that's used in the YouTube instructional videos. So you can actually go through these, and I describe where the whole thing is built step by step. The actual example is installed with Messenger Library, and I'll show that now. Let's see, where is it? Oops.
So there is a question that came in on that previous slide of yours.
Okay.
It says, can you scope a messenger so that the other entities can subscribe to its messages, but not send messages as an imposter?
Well, I might not get across. In Messenger Library, there's no global accessing of addresses. So if a caller creates an address, only the caller has access to the address. And when the caller sends a registration message that containing the address, that address is sort of protected. So there's a lot of control over where usually only the caller ever has the ability to send an arbitrary message to something.
I think that answers the question.
Let me go further. Okay, so this is the more complicated example, and it's a top-level actor. When I start the top-level actor, it launches an instrument actor, and that's weird. What is that? Oh, I know. Anyway, this never mind. This is actually the same data that has been sent back from the instrument actor to the main actor, and the main actor has 3 controls: amplitude, frequency, and period. Same ones here. Whenever the main actor changes the period of the phase, it changes here. Let me clear these so it's a little more correct. It's actually the same data. And so all these things are slaved together. In fact, I can launch, call a new UI, user interface, and this is hooked in together too. As I change the controls here, if you look at all the other things, they change with it. I can make a bunch of UIs if I want. And everything is slaved together, and all slaved together with messages. If you look at all these things, these are all the same template. The instrument is the same template. And they all have extra code in them. Let me just stop one. I'd like to point out that I just stopped my entire complicated multi-actor application by hitting the stop button. That might confuse some people. I can run the instrument by itself. So one of the design principles I follow is that you debug something by itself in pieces and then put it into the more complicated application. So the template is designed to be able to stop itself, to run and stop by itself. And then when I've got it mostly debugged, you can use a higher level actor to call the lower level one.
So that's actually the place for this question to break in. Since message names are strings, you talk about higher level actors calling lower level actors, your application gets larger. How do you manage all the message names? In a large app, this must be quite a challenge.
Well, again, the messages are only going from callee to caller usually. I mean, they're not. I don't care if one thing understands a read. If actor A sends reading to actor B and actor C sends reading to actor D, it doesn't matter that the name is the same.
So really, what you're looking for, though, is as long as within any given scope the names are unique, you can.
Yeah,
then,
scope is important.
For example,
some types of frameworks I've seen are very global in scope. So if you register everyone with a central message handler, you got to have unique names. But this does not have, by default, any kind of global scope. It's a very, very tight and local scope.
Okay.
So my most common thing is an actor will launch a, let me go further and you'll see a bit.
Okay.
So anyway, if you look in this, again, there's lots of more moving parts, so it gets confusing. But all the things that I showed before with the simple examples are there. So here, for example, I'm launching, sending a message show front panel. I'm sending a registration message for reading amplitude, period, and frequency. I'm translating by adding instrument 1 so that the messages are altered to something that makes more sense to me. And then I have a message handler which handles all the instrument 1 things coming in. So I'm building up my structure with these, what I think of as simple things I showed before.
So is there a way to document easily? Jacob says there's a question, what are the messages that are acceptable and expected for a given actor to receive?
Well, I would say here, there's a list. So because the actor is just one loop and it's got this single place for handling messages, you can see what it could possibly handle. As far as its sub-actors, because the caller launches all its sub-actors and registers, this actor cannot receive a message from its sub-actors that it's not expecting, because it's got to explicitly register for the messages it wants. If the sub-actor has another message, blah, 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 ABC, whatever, it can't get that message to its caller.
Okay, so I think to answer Matt's question, if you're trying to find, as a programmer, you have an actor in your hand, you want to send messages to it, you go to this VI and you find its case structure, and there's your list.
Yeah.
Okay.
I realize that's kind of a weakness. But it's difficult to say how you can go through code and get a list of what things it could accept.
This is a question for me. Do you ever create specific send VIs that are just, they have the message string already embedded in them?
Sometimes what I do, if an actor is going to be used in by a lot of callers, you can write an API. So you have an actual class for your actor, and that class is what's serving as the object. So you can make methods of the actor that take the actor and only the actor's address and does stuff with it. So it's possible to build an API, and that's worth doing if you're going to use it in a lot of different places.
Okay.
But I don't normally do that. Okay. So what time is it? Let me just check the time. Okay. So I'm going to go through some diagrams of what's there rather than go through all the code. So again, I showed this where you launch instrument 1, tell it to show its front panel, register for information, including the reading, to put a prefix to more identify the information. So what we get back is not reading, it's instrument 1 reading. So this is the sort of the messaging pattern we just set up. When we launch that little UI thing, it's slightly more complicated. So the top level launches the UI, and then it sends registration messages to both instrument and the UI to connect them to each other. So top level is not like in the actor framework serving as the central thing, but it's setting up the communication method, telling these two things and hooking them together. So what it's done in this case is it's registered for amplitude, period, and frequency for both of them. And then it's modified the message so that it's basically translating the messages so they serve as commands to each other.
When you
so
do you do have multiple that are going to be broadcasting out, if you were to like set up 3 or 4 of those pairs there that you've got,
yeah.
Do you enqueue the message twice, or how does it handle broadcasting of messages?
Well, it's not broadcasting, right? So this control server is hooked to sending to instrument. If I make another one, it's also sending to instrument. So if I change one of the control servers, I showed that before where I moved one control and it changed all the others. It's sending that control I'm moving is sending a message to the instrument, and instrument is sending to everything else that's registered to it. I'll probably do that. Hang on.
Diego, I think that answers your question.
Yeah. So I make a few of these guys. They all hook together. Let me go with this guy, and I will put a probe on the message. And then I'll control a different one. As I move this, messages fire in. Those messages are going to the instrument. This is changing the instrument, and the instrument is broadcasting to everyone else. So you see that it runs around. So even though I've got many different of these, they're all hooked together. They're not actually hooked together. They're all hooked to the instrument. This guy sends a message to the instrument, and the instrument sends a message to everybody. If I look on the instrument and I look at put a probe on the observer registry. Hang on. Yeah. Custom probes and bugs. If you look at the probe in the observer registry for amplitude, there are 4 observers. One is add prefix instrument 1 and go to an event messenger. That's the top level. And then there's 3 others that basically wrap control servers. And they all add an outer envelope. Can you see that? So add prefix 1 is going to the event messenger. That's the top level. And then put in an outer envelope, set control, and send to a control server 3 times for the 3 different ones. So that's because they're all hooked together like this. And I looked in the instrument, put a custom probe to see how these are all registered. One other thing to talk about in the instrument is sending messages periodically. It's taking readings. And the way it's using that is using a utility actor called the metronome. That's this guy. Again, this is an example of we're talking about, can you make an API for your actors? The metronome, I've made a little API method. So rather than actually launch it, I'll just put that all in a method. And here I launch the metronome with a certain period, and then I relabel the messages coming from it. It just sends messages at a periodic rate. Call them take reading, and then I receive the take reading messages in my event handler. Call take reading in my follow-on action, notify reading, and actually take the reading. So that structure looks like this. So the metronome, this registers for the metronome tick messages. I go take reading, I take the reading, and I actually broadcast the reading. So again, I'm trying to show how you actually, all these things are actually, to my mind, simple, right?
Right.
I've got a simple component that sends messages. I make an address, I do things, but it actually builds up to more complicated structure.
Got another question here from Matt Jacobson. Do you tend to do much in the event frames? When he used the library for a simple project, he mostly just passed information right onto the state machine.
Well, the reason I do this here is often if the take reading only ever happens in the event, then I just do it there. But so often you have information you find you want to take it in the event, but also you want to take it on initialization, or you also want to take it for some other reason. So you end up with more than one thing happens, calls the same code. So this is putting it here, gets into common code. If you're sure it's never going to be anything but done when this event happens, then you can put it over here.
Okay. Dennis has asked, can you also send LV class data to change the type of the instrument like OOP? I'm not sure if he's asking about the state pattern or if he's asking about class data as the actual data payload.
I'm not sure of that question. If I had a different instrument and I wanted to say I want to use some kind of hardware abstraction, I can either have, here I've done it, often when I have an instrument, I have a class in this data. And the class is sort of a driver for the type of hardware. And the class has like initialize, take data, set control, whatever. And then I use that inside my actor. So I sort of have two stages. And then I can either swap out hardware by swapping out this class for a child class, actual hardware abstraction, or I can swap out the entire actor for a different one that handles the same messages. So this is kind of the actor there isn't any kind of inheritance in Messenger Library, but you can build an actor that takes a common set of messages and then they can swap out.
Okay. That's all the questions we got currently, if you want to keep going.
Okay, carry on. That just quickly shows how set period works. When the top level changes the period, it sends a message. The message calls new period. Period sends a state notification for the period to everyone else. And also sends the set period message to the metronome actor. So it actually goes through and just goes this cascade of messages. It's quite quick to build up messaging interactions in Messenger Library because they're just strings, basically. Strings and simple messages with simple bits of information. And again, what time is it? I may skip this. This is just to show different ways of doing periodic actions that Messenger Library has. And basically, there's more than one way to get a single loop to do to handle more than one thing at a different rate. So for example, if I had a loop and I wanted to check for new data every 100 milliseconds, but also send a keep alive message to someone to show that I'm still working every 60 seconds, and do something like delete some old log files every 24 hours, I can do that with the same loop because I just need 3 different metronomes at different rates telling me to do things. So I can have a metronome that says check for new data, a metronome that says send keep alive, a metronome that says delete old files, and they can all go at their own rate. I find this is simpler than having 3 different loops to do 3 different things because it leads to fewer loops because your one loop can do multiple things.
It does also help prevent you from doing two things at the same time if you're trying to actually, control resources and such.
Yeah, that's advantage, because your one loop is one brain, and it's got one set of resources, and it's serializing these actions. They're at different rates, but it's not going to try to take data while I'm deleting old files.
Right,
or write to the log
while you're deleting the log.
Say again?
Or try to write to the log while you're deleting the log.
Yeah, exactly. Because you're kind of serializing things that might interfere with each other if they happen at the same time.
So one question that they were trying to clear is you can send an object as data, right?
Oh, yes, yeah.
Okay. They were just, a couple of people were kind of flagged that.
I've done that a lot. Have an actual data object or a tests to execute object or a test results object that are just sent around in a message.
If the reading hardware hangs and then fixes itself, will the metronome tick messages build up? How do you handle that?
Maybe I shouldn't have skipped this start. So that's why there's more than one way of doing a periodic action. So the one on the left is a metronome, which is a thing that sends messages at a steady rate. If you send a message every 100 milliseconds and you kind of zone out for a second, you'll have 10 messages stacked up. And so you have to handle those 10 messages. If you don't like that, the other way of doing a periodic action is to send a message to yourself, a delayed message. So when I receive a message, I handle it, and then I send it with a 100 millisecond delay to myself. And the advantage of that is if you zone out for a second, you will still only have one message stacked up. So It depends that you have to decide what your behavior is. If you miss, do you want to drop things or do you want to handle them, a stack of them?
Here's a really deep question that we all get asked when we present one of these things. There are always trade-offs in a framework. Can you talk about what philosophy limits what features you will put into your framework? For example, there is no inheritance in your library. Is there a reason?
Yes.
That's one example.
It is trade-off. It is trade-off. It is an idea of coming out with a consistent set of what is possible that you think is the best trade-off. So I think my trade-offs are better than actor framework, but I don't think my framework is better in everything. It's better in that it's got advantages and disadvantages, and the advantages mean more to me than the disadvantages. But to someone else, it might be different. So I'm more likely, as far as inheritance, if I have I want inheritance, I might have a single actor that takes, as part of its configuration, an object that it uses, and that object can have inheritance. So it's composition rather than direct inheritance.
I might take a moment to throw in here that Dr. Powell is one of the people who helped me design the actor framework, and these two systems came up at the same time. Just because we came to different conclusions, we were solving slightly different problems. So Kevin's question is excellent. It is about what you're trying to trade off against.
Yeah. Where are we going? So we're going to have to move forward if we have time. Sorry, my program was very small. I'm going to skip this one, but to mention that I showed you a bit, custom probes that install with Messenger Library called cyclic table probes, and they are designed to handle looking at messages that come in. And I was going to go through, if I had time, to show some of the messages that the template gets. The template always has a self-initialized message first and uses a self-auto shutdown message to shut down if its caller shuts down. But anyway, what I really want to talk about is some architecture. So these are just some architectures that I come across in the actual applications I've done with Messenger Library. Some of the patterns, some of the basic patterns. So the first basic pattern is tree-like. And AQ will know this because the actor framework strongly favors this kind of structure. That's where you have one top-level actor, and it creates some sub-actors, and those sub-actors might create sub-actors. And the messaging pattern is very much caller to callee and back and forth. The difference in Messenger Library from actor framework is that the top level sends registration messages and requests down, and what comes back is replies and notifications. So there's an asymmetry that's not so much in the actor framework, where basically the top level acts on the callees, and the callees are just dumb providers of information back. Now, another small thing I come across a lot is called lender resource. Lender resource is where the top level creates the resource A, then creates something to use A, and passes A as an and then passes A at the address of A to the user of A. This is kind of a break of what you would see in the active framework, and this is commonly comes up when it's hard to describe this. Often you get where A is a resource that lives a long time, like the whole application. Maybe it's running a piece of hardware. User of A might be, say, calibrate hardware, something that is short-lived but must use the hardware. So user of A can't create the hardware because the hardware exists before user of A exists. But user A must be able to control A. And in that case, the top level is sort of the manager of the lifetime, but it's not going to really use A. It creates something else to be the user of A. And it might create user of A to calibrate the instrument, then create something to take data with the instrument. So that's called a lender resource, and it's very much of a service kind of architecture. And another architecture I've used a lot is basically manager and snapping together. That's where a manager actor creates a bunch of actors and then snaps them together with registration messages. So you might say A is a data producer, B analyzes the data in some way, E saves the data, D displays the data. And the manager knows all these things, sends registration messages to hook them all together so they send messages to each other. That's what I showed earlier with the little UI thing, which was connected to the instrument by the top level. The top level wasn't involved in the messages, but it was hooking them together. And my suggestion there is to think that the manager is like a white-collar worker. The manager isn't actually doing the work. That's what all the workers are doing. But it sets up and shuts down and reconfigures the workers. The advantage of the manager not being, unlike in the active framework where messages go through the manager, the advantage of the manager not being involved in the main work is it's free to block doing complicated multi-step actions. So it can say, tell A to stop, shut down B, create B2, snap it in place between A and C, and change things. So this is the kind of architecture. This is a common architecture I use when I'm making some kind of scientific instrument that uses some kind of pipeline of data analysis. And often when you do this, I'm going to show this because there's actually 2 talks about future tokens at this conference, which I recommend. Messenger Library has future tokens, and I use them for dealing with multiple actors at once. So in this case, the manager wants to get information, let's say configuration, from all these actors at once. It doesn't want to talk to them individually. It wants to deal with them as an array. And so it sends a message to all of them, and it wants all the replies together in order. So it doesn't want to handle all the messages coming in at different rates. So if I scatter a message to all these actors, the replies will come back at different times. And the manager can use future tokens and something's called a temporary gatherer, which waits for all the future tokens to be filled and then sends an array of replies to the manager. And this is some of the API where basically there's 2, again, there's synchronous and asynchronous. Redeem future tokens, waits for all future tokens to receive messages before replying all the messages. And then this is the asynchronous version, which waits for all the future tokens and then sends a bundle of messages to an address. So here's what an example is. Array of addresses, get configure as JSON message, provide a future token as the reply address, wait for them all to come back, get the information. And the thing is that the information, the array of JSON strings is in the order of the initial array of addresses. That's the important bit. So that's an example of the future token. And you should see that one or both of the talks about futures in LabVIEW. One last thing I want to talk about, because it's kind of interesting, a little more complicated, is a distributed architecture where you might have more than one application that interact with each other, perhaps on different computers or perhaps on the same computer. Here's an example of the structure where you have a client application and a server application, and they use TCP messengers, client and server, to connect together. Once they do that, because the TCP communication method understands replies and notifications, you can actually treat it as if the server was a branch of your client. All the replies and notifications are routed back through the TCP connection. So it makes doing a distributed architecture quite easy. And then having said that, TCP is never quite easy. And that's because connections are unreliable. If you have a TCP connection and you start a program, you might never be able to make the connection, or your TCP connection can be interrupted at any point. So it's never as simple as I show here, because you can never treat this branch as just another branch, because it's an unreliable branch. And to fight that, one of the features of Messenger Library is called a watchdog. A watchdog is an asynchronous process you just launch, and it watches an address, and if the address dies, it sends a message to where you set it. So here's over here, the watchdog is basically monitor this address. If it dies, send a message to this other address to say it's died. And basically, it allows you to build up a reliable application that can detect a break and reestablish the communication. One other interesting thing is this watchdog, which is called a timeout watchdog. Often we have timeouts of a timeout watchdog. You have to see the example. The timeout watchdog allows you to say, this piece of code should execute every 60 seconds. If it doesn't execute, send me a message. And that can be put anywhere in your code and is useful for telling if something is actually working. And if it doesn't work, trigger some code to try and recover. I don't think I have time to show this, I'm afraid. Yeah, so let's keep talking.
Question for you here. How does your messenger library perform on CRIO? Is the TCP messenger suitable for transferring data from CRIO to PC?
Yes. I've done it once to test. More than one person has actually helped me develop to make sure that it works on CRIO. Is that true? I wish I had more experience doing it as an actual project. I have actually put it on single board RIO.
On RT. I don't know if it was a CRIO specifically.
Yeah. It doesn't use anything that shouldn't work. It's just basically TCP. I can show you if you want. Hang on. Maybe I'll use my last bit that way. If I can find. So where's the TCP? So here's my server. And if I start the actor manager, you'll see that this simple receiver that I've started has started an actor. And this is the TCP listener actor. And that is waiting for connections. When I start this guy, and remember this guy is very, very simple. Come on, update. Thank you. It has started a client actor, TCP client actor. And the listener actor has started a TCP connection actor. So the connection and the client are now communicating and passing messages back and forth. I forget which way it goes, but let's have a look. If you look at these actors, they're two loop actors based on a queue. They have basically, because they're bidirectional communication, the top loop is handling communication one way, and the bottom loop is handling communication the other way. So let's see if we can find the messages. So yeah, there's the message I told you. Since the value of TCP, the count is coming this way. So anyway, this doesn't use any kind of communication that wouldn't work on a RIO. Just basically the TCP. Is it send via TCP? Yeah, it basically takes the message, takes the internal message, flattens things, and sends it via TCP. So I remember, yeah. There is zlib compression, which you have to turn on because sometimes you don't have that library loaded. But I have tested it on a single board RIO. The one last thing for anyone who actually uses Messenger Library with TCP, the latest thing I've been working on is called a Reconnecting TCP connection to make it even easier to connect things together that might temporarily lose connection and reestablish. It basically reestablishes connection and keeps all the registrations live so that they keep working. So in summary, Messenger Library is a long-tested package that's available on the Tools Network. there's actually 3 possible levels of use. You can use the addresses and messaging, as I showed in the simple examples yourself. You can use the actor launch, which is basically make an actor. Again, I showed you a very simple actor. Or you can use my DEV template, which is more complicated, but I think is kind of, it's got all the capability that you need to build a really good application. Messenger Library has very good support of messaging patterns, both synchronous and asynchronous. Again, you're trying to start with simple things and build complexity into the messaging patterns rather than make complicated components. It's got good TCP capability and good debug tools. And thank you. That's it.
Excellent. One final question that's open here. Is the Reconnecting TCP concept open source and available for use?
I have not built it into our application yet. I haven't built it yet. It's going to go into the next version of Messenger Library. It's in the public repo.
Got it. I think that takes care of the questions in the backlog. There's a lot of applause and congratulations for you.
Oh, good. Thank you. Can't hear anything.
So there are a fair number of people watching that appreciated it. I will throw in that I've got a lot of respect for this framework. There's a lot of good work that's gone into it. And as usual, when we talk about these things, we really don't, it's not important which framework that you pick, or even if you decide to roll your own, as long as you understand why each of these frameworks did what it did, and you play by the rules of the one you pick. You'll be far more successful.
It's important not to duct tape things together.
Yep.
Like sometimes people say they take the actual framework and they say, I like the actual framework, but I don't like that you have to pass messages around, so I'm going to use some tag-based thing as well. And I think they're making a more powerful framework, but actually they're breaking the actual framework. They're bending it to an incorrect use. Correct.
And yeah, there's several places where we've seen that with whether it's DQMH or this one or Lapdog. There's a lot of them that crops up. So
yeah.